So hello guys, for today's video, we're going to summarize the chapter 1, which is the Explore the Network. So network supports the way we learn. So network supports the way we learn. Networks change the way we learn. Access to high quality instruction is no longer restricted opportunity. Online distance learning improves student opportunity. They deliver learning material in a wide range or formats, including interactive activities, assessments, and feedback. And the next one is network supports the way we communicate. So some forms of communication include like texting, social media, collaboration tools, wikis, podcasting, peer-to-peer file sharing. So in the business, world data networks initially used by businesses to it is in the network supports the way we work. In the way we work, in the business world, data networks initially used by business to internally record, manage, and financial information, customer information, and the use of networks to provide efficient, cost-effective employee training is increasing and decrease the consuming and costly travel, yet still ensure that all employees are adequately trained. And network supports the way we play. Networks enable the creation of new forms of entertainment such as online games. They can participate in any kind of online competition, compete with friends and foes around the world as if we are still in the same room. And in the types of networks, so we have here the different types of networks. So first one is the local area network. Local area network, it is a network infrastructure that provides access to users and devices in a small geographical area, which is typically an enterprise, home, or small businesses, a network owned and managed by an individual. And the wide area network, it is a network infrastructure that provides access to other networks over a whole geographical area. And it is typically owned by or managed by a telecommunication service provider. So we have here other types of networks, which are the metropolitan area network, wireless LAN, or the WLAN, and the storage area network. So the metropolitan area network, it is a network infrastructure that spans a physical area larger than a LAN but smaller than a WAN. So MAN are typically operated by a single entity such as a large organization. And the WLAN, it is similar to LAN but wirelessly interconnects users' endpoints in a small geographical area. And the last one is the storage area network, or the SAN. It is a network infrastructure designed to support file servers and provide data storage, retrieval, and replication. So hello guys, so for today's video, we're going to summarize the chapters 1 to 11. So we are now here in chapter 2, which is the configure network operating system. So as you can see, this is the operating system, or the iOS bootcamp. Shell, it is the user interface that allows user to request a specific task from the computer. This request can be made either through the CLI or GUI interfaces, communicates between the hardware and software of a computer, and manages how hardware resources are used to meet software requirements. Hardware, it is the physical part of a computer, including underlying electronics. So in access method, we have here the console. A console is a physical management board that provides out-of-band access to a Cisco device. And the secure shell, it is a method for remotely establishing a secure CLI connection through a virtual interface over a network. And the telnet, it is an insecure method of remotely establishing a CLI session through a virtual interface over a network. In configuration command modes, we have here two common sub-configuration modes include line configuration mode. It is used to configure console, secure shell, telnet, or the auxiliary access. And the interface configuration mode used to configure a switch, port, or router network interface. Navigate between IOS modes, we have here enable, disable, configure terminal, exit, line, and or control plus Z. And we have here different kinds of hotkeys and shortcuts. So tab completes the remainder of a partially typed command or keyword. Control R displays a line. Control A moves to the beginning of the line. Control Z exits the configuration mode and returns to user exec. Down arrow allows the user to scroll forward through firmware commands. Up arrow allows the user to scroll backward through firmware commands. Control-Shift-6 allows the user to interrupt an iOS process such as ping or traceroute. Control-C exits the current configuration or aborts the current command. Secure device, securing administrative access, secure privilege exec access with a password, secure user exec access with a password, secure remote telnet access with a password, and the other task is encrypt all password and provide legal notification. And in securing device access, these are device access password. The enable password, which limits the privilege, the exec mode, and the enable secret, encrypted limits access to the privilege exec mode, and the console password limits device access using the console connection, and the VTY password limits device access over telnet. And service password encryption prevents password from showing up as plain text when viewing to the configuration to keep unauthorized individuals from viewing password in the configuration file. So in banner messages, we have here important part of the legal process in the event that someone is prosecuted for breaking into a device, and wording that implies that a login is welcome or invited is not appropriate. So end of slide. So we're going to proceed to chapter 3. So this is chapter 3, which is the network protocols and communication. So rules establishment, unidentified sender and receiver, common language and grammar, speed and timing of delivery, and confirmation or acknowledgement. In network protocols, we have here protocol interaction. So protocol interaction, a communication between a web server and web client, is an example of interaction between several protocols. The HTTP is an application protocol that governs the way a web server and a web client interact. And the TCP, it is the transport protocol that manages the individual conversation, and the IP is responsible for taking the formatted segments from TCP. And the Ethernet, it is a network access protocol that describes two primary functions. So in TCP, IP protocol suite and communication process, so we have here three kinds of layer, which is the application layer, transport layer, four, which is the Ethernet layer, and the network access layer. So in application layer, the DNS, BOOTP, DHCP, SMTP, POP, IMAP, FTP, HTTP. So DNS stands for Domain Name System. BOOTP stands for Bootstrap Protocol, and the DHCP, which is the Dynamic Host Configuration Protocol, and the SMTP is the Simple Mail Transfer Protocol, POP for Post Office Protocol, then IMAP for Internet Message Access Protocol, FTP File Transfer Protocol, and So it has a lot of kinds of layers. So this is the end of slide, so we must proceed to chapter 4. So chapter 4 is the network access. So as you can see here, the physical layer media, as you can see, the electrical signals, light pulse, and the microwave signals. So electrical signals is a copper cable. The signals are patterns of electrical pulses, as you can see, and the light pulse, which is the fiber optic cable, the signals are patterns of light, as you can see. And the wireless signals, which is wireless, the signals are patterns of microwave transmissions. And copper media, there are main types of copper media used in networking: the unshielded twisted pair, and the shielded twisted pair, and the coaxial. So the unshielded twisted pair cabling is the most common networking media, and the shielded twisted pair, it provides better noise protection than UTP cabling. And the coaxial cable, or COX for short, it is a copper conductor used to transmit the electronic signals. And these are the UTP cabling standards and the common physical one topologies. So we have here the point-to-point topology. This is the simplest topology that consists of permanent link between two endpoints. And the hub-and-spoke topology, a one version of star topology in which a central site interconnects branch shoots using point-to-point links. And this one, full mesh topology, provides high availability but requires that every end system be interconnected to every other system. Common physical LAN topology, so we have here star, extended, bus, and ring. So the star and devices are connected to a central intermediate device. The extended star is a additional Ethernet switches interconnect, and the bus are all end devices are chained to each other and terminated in some from on each end. And the last one is the ring, and systems are connected to their respective neighbor forming a ring. So end of slide. So let's proceed to chapter 6. No. In chapter 5 rather. So chapter 5, which is the Ethernet. So data encapsulation provides three primary functions, which is the frame delimiting, the error, the addressing, and the error detection. So frame delimiting is the framing process of provides important delimiters that are used to identify a group of bits that make up a frame. And the addressing, the encapsulation process contains the layer 3 PDU and also provides for data link layer addressing. And the error detection, each frame contains a trailer used to detect many errors in transmissions. And frame forwarding methods on Cisco switches, the store and forward switches, and the cut-through switching. So a store forward switching receives the entire frame and computes the CRC. If the CRC is valid, the switch looks up the destination address, which determines the outgoing interface. And the cut-through switching forwards the frame before it's entirely received. And memory buffering on switches. So we have here the port-based memory. In port-based memory, frames are stored in queues that are linked to a specific incoming and outgoing ports. And the shared memory, it is shared memory buffering deposits all frames into a common memory buffer which all the ports on the switch share. Introduction to ARP: when a device sends an Ethernet frame, it contains these two addresses, the destination MAC address and the source MAC address. So end of slide. So we must proceed to chapter 6, which is network layer. So the network layer uses for basic processes the addressing end device. End device must be configured with a unique IP address for identification of the network. Encapsulation. The network layer encapsulates the protocol data unit PDU from the transport layer into a packet. And the routing. The network layer provides services to direct packets to a destination host on another network. And the encapsulation, when the packet arrives at the network layer of the destination host, the host checks the IP header of the packet. Then, in IPv4 packet header, significant fields in the IPv4 header include the version, differentiated services or different serve, and time to leave, protocol, source IPv4 address, and destination IPv4 address. In introducing IPv6, improvements that IPv6 provides include increased address space, improved packet handling, eliminates the need for NAT. The IPv6 advantages, its simplified header format for efficient packet handling, larger payload for increased throughput and transport efficiency, also hierarchical network architecture for routing efficiency, and IPv6 packet header, significant fields in the IPv4 header include the version, traffic class, flow label, payload length, next header, hop limit, source IPv6 address, and also the destination address. So, end of slides. Proceed to Chapter 7. Chapter 7, which is the IP addressing. So, in IP addressing, the IPv4 communication, a host successfully connected to a network can communicate with other devices in one of three ways, which are the unicast, broadcast, and the multicast. So, the unicast is the process of sending a packet from one host to an individual host. And broadcast is the process of sending a packet from one host to all hosts in networks. And the multicast is the process of sending packet from one host to selected group of hosts. And public-private IPv4 address. Public IPv4 address are addresses which are globally routed between ISP or the Internet Service Provider routers. There are blocks of addresses called private addresses that are used by most organizations to assign IPv4 address to internal hosts. Legacy class full addressing, we have here three classes, which is the Class A, Class B, and Class C. Class A designed to support extremely large networks with more than 16 million host address, and the Class B is designed to support the needs of moderate to large networks with up to approximately 65,000 host address, and the Class C is designed to support small networks with a maximum of 254 hosts. So, end of slide. So, we must proceed to Chapter 8. Chapter 8, which is entitled the Subnetting IP networks. So, assigning address to devices, end user clients, servers and peripherals, servers that are accessible from the internet, and the intermediary devices, and then the what we call the gateway. So, in next, so the IPv6 global unicast address, in IPv6 global unicast address structure, the what we call the global routing prefix, this is the prefix or network portion of the address that is assigned by the provider, and the subnet ID, it is used by an organization to identify subnets with its site, and the interface ID, this is the equivalent to the host portion of an IPv4 address. The term interface ID is used because a single host may be multiple interfaces, each having one or more IPv6 address. And subnetting using the subnet ID, the 16-bit subnet ID section of the IPv6 global unicast address can be used by an organization to create internal subnets and so on and so forth. Then, here we go. Then, we must proceed to Chapter 9. Chapter 9, which is entitled the Transport Layer. So, TCP transport is analogous to sending packages that are tracked from source to destination. If a shipping order is broken up into several packages, the customer can check online to see the order of the delivery, and also yung in the UDP, it is provides the basic functions. The basic functions for delivering data segments between the appropriate applications with every little overhead and data checking. UDP is known as best effort. Delivery is referred to as unreliable because there is no acknowledgement that the data is received at the destination. But also it is similar to placing a regular non-registered letter in the mail. So in TCP features, the establishing session, the reliable delivery, same order delivery, and the flow control. So next, so the TCP header, each TCP segment has 20 bytes of overhead in the header encapsulating the application layer data. So the source port, it is used to identify the application, 16 bits, sequence number, used for data reassembly purposes, 32 bits, acknowledgement number, 32 bits, indicates data has been received and the next byte expected from the source, header length, known as data offset, 4 bits, reserved, 6 bits, the field is reserved for the future, and the control bit, 6 bits, includes bit codes or flags which indicate the purpose and function of the TCP segment. And the window size indicates the number of bytes that can be accepted at one time. And the window size indicate the checksum, 16 bits, used for error checking of the segment header and data. Urgent, 16 bits, indicates if data is urgent. And in transport and TCP connection establishment have 3 steps. So step 1, the initiating client requests a client to server communication session with the server. Client 2, the server acknowledges the client to server communication session and requests a server to client communication session. Step 3, the initiating client acknowledges the server to client communication session. And the applications that use TCP is the application, there are 3 types of applications that are best suited for UDP. The live video and multimedia applications, simple request and reply applications, applications that handle reliability themselves. So end of slide. So we must proceed to chapter 10. Chapter 10, which is entitled the application layer. So presentation and session layer. The presentation layer has 3 primary functions: formatting or presenting data at the source device into compatible form for receipt by the destination device, and the compressing data in a way that can be decompressed by the destination service, and the encrypting data for transmission and decrypting data upon receipt. And the session layer, as the name implies, functions at the session layer create and maintain dialogues between source and destination applications. The session layer handles the exchange of information, to initiate dialogues, keeps them active, and restart the session that are disrupted or idle for a long period of time. And the client-server model, is the device requesting the information is called a client. Client and server processes are considered to be in the application layer. And the peer-to-peer networks is the data is accessed from peer device without the use of dedicated server. And the peer-to-peer applications allows a device to act as both client and server within the same communication. Protocols, one of the primary services offered by an ISP is email hosting. Email supports 3 separate protocols for operation: the simple mail transfer protocol and the post office protocol. So end of slide. So we must proceed to the last chapter, which is the chapter 11, which is entitled the build a small networks. So in chapter 11, so we have here common application, which is the network applications and the application layer services. So, network applications are the software programs used to communicate over the network, and the application layer services is other programs may need the assistance of application layer services to use network resources like file transfer or network print spooling. And the common network protocols comprise the fundamental toolset of network professional. Each of these protocols define process on either end of communication session, type of messages, syntax of the messages, meaning of informational fields, how messages are sent and the expected response, and the interaction within the next lower layer. And the types of threats, so we have here 4 different types of threats. So information theft. Information theft is this is breaking into a computer to obtain confidential information. And the data loss and manipulation, breaking into a computer to destroy or alter data records. And the identity theft, it is a form of information theft where personal information is stolen for purpose of taking over someone's identity. And the disruption of service, preventing legitimate users from accessing services to which they should be entitled. In physical security, the 4 classes of physical threats are the hardware threats. It is a physical damage to servers, routers, switches, cabling plant, and workstations. And the environmental threats, temperature extremes, and electrical threats, voltage spikes, insufficient supply. And the maintenance threats is poor handling or key electrical components. And the types of malwares, the viruses, worms, Trojan horses. Also different types of attacks is the reconnaissance attacks, access attacks, and the denial of service. So we have here 6 steps of troubleshooting methodology. Step 1, we're going to identify the problem, and then step 2, after we identify, we're going to establish a theory of probable causes, and step 3, we're now going to test the theory to determine the causes, and step 4, establish a plan of action to resolve the problem and implement the solution. Step 5, to verify full system functionality and implement preventive measures. And the last one is document findings, actions, and the outcome. So, on the slide, so this is my summarization of chapters 1 to 11. So, thank you for watching.